Okay, students, so we are in quarter 4, week 3, and we're going to continue with some more circle ideas. So this week we are going to focus on inscribed angles. So an inscribed angle has the middle of the angle or the vertex on the circle this time. Central angles went through the center, but this time an inscribed angle, you have the sides like this. If we extend out, we can see it as an angle. So these are the sides, RQ and RS, and the vertex is R, so it's inside. This is the angle that we're referring to. Now, we have another term called intercepted arc. So if you extend the sides of the angle, the arc goes from side to side. So it would be arc QS. Okay, so the inscribed angle is angle QRS, and its arc is QS. All right, there are 3 different ways that these inscribed angles can be drawn, so I want to just kind of show you. So the first way is if one of the sides of the angle actually goes through the center, which would make this a diameter, okay? And so that has some special numerical relationships because remember, a diameter cuts your circle into half, so that could be useful later on. The second case is when we have the inscribed angle and it's kind of straddling the center. All right, so here we go. And then the third kind of inscribed angle doesn't include the center at all, and it's just to one side of it, okay? So it doesn't matter. They all have the same ideas and relationships, and they're all still inscribed angles, okay? So let's think about the size, though, because that's what we're going to focus on. So if you have an inscribed angle, like angle 1, the rule is that if this is its arc, the angle is equal to half of the arc. So when we had central angles, because this could still show up on some of these problems, a central angle, if the angle was 50, its arc was 50. They were the same. But an inscribed angle, where our vertex is not at the center, if angle 1 is 50, I'm going to do the angle is half of the arc. So I had to take half of some arc to get 50. So if we double the arc, or 2 times the angle, is equal to the arc. These are both the same idea, so we know its arc would be 100. Okay, so we can still use some ideas from last week on central angles that could help us with the inscribed angles and arcs as well. It just kind of depends on the picture. Most of the problems shouldn't, though. So let's do some examples. We do still want to review how to identify what we're looking at based on how it's named, so keep that in mind. So on the first example, it says find each measure, and so we want the measure, which means the size, of angle P. So angle P, that's not my favorite way to name it because I like 3 letters, but if they only use 1 letter, then you know you're referring to the only angle P that is created by the diagram. So I noticed that P is on my circle, so I know that that's an inscribed angle. And so I need to find its arc. What I do is I like to extend the sides, so then I know the arc goes from side to side. So its arc is 70. So remember, my angle is equal to half of the arc, or 2 times the angle, but we don't have the angle, we have the arc. So I know my arc is 70, so half of 70 gives us 35. So I'll go ahead and label that. All right, second question, find arc PO. So let's go to PO right here. And so, well, I know that's an arc and it doesn't have anything to do with the pink measurements. So if that's on an arc, I need to find the angle that it's being related to. So we're going to look across and it looks like we have this inscribed angle. So we also know that 2 times the inscribed angle is equal to the arc. So now we know the angle is 56, and so 2 times 56 is 112, and that equals the arc. All right, so we can use that relationship either way. Let's try some more. So let's look here. It says find the measure of arc CF. So CF, all right, that's on the circle. I need to find an angle that it's relating to. So I'm just going to go where F ends and where C ends, and it looks like we have an inscribed angle this time. So if I want the arc, I know the angle is equal to half of the arc, but I have the angle, so I want to do 2 times the angle is equal to the arc. So 2 times our angle is 40, and so 80 equals the arc. Okay, so keep in mind, depending on what you have, might depend on which rule is easier to use. All right, and then let's look at find the measure of angle C. So I'm going to erase this. So if we want angle C, I'm looking for that angle right there. So I'm going to go ahead and extend these sides. And I want this, okay? So 40 has to do with D. So if this is my angle, the arc that it's across from is DE, which is 98. So angle is equal to half of the arc. So I know the arc is 98. So my angle is equal to, take 98 and divide it by 2, and we get 47. Okay. All right, let's try something that look a little more complicated. So on this example, I have this arc is 60, and if I go across and connect, I have an inscribed angle. So our angle is equal to half of the arc, and we know the arc is 60. So half of 60 gives us 30. All right, my next example is a little more complicated. So we're going to utilize the idea of a whole circle and the total of its arcs. So I don't know the angle and I don't know its arc, but I know this is 107 and this is 135, and all three of these make up a whole circle. So from last week, a whole circle, the arcs have to total 360. So we're going to take off 135, because that's how much we know, but we don't want that. And then if I take off 107, so 8, 1, 1, well, if I had the whole circle and I took those off, this is how much is left for arc XY. So now I know that arc length. And if we have the arc, I can take half of it to find the angle. So 118 divided by 2 is 59. There we go. All right. So that was a little more steps and use some review information. So let's look at our next example. We have this kind of trapezoid quadrilateral looking inside, but don't think of it as a whole shape. Just keep thinking of inscribed angles somewhere because that's what we're focusing on. So the first thing I know is I want to find this angle, and if I extend the sides, I know it's related to this arc, BXY. And I don't know either all of it or any part of it at all. But if I think of that as all one big arc, we do know this is 90, arc ZB, and arc ZY is 144. So it's the same idea that we used on the last problem. It just looks like a different shape to try and trick us. So we know the total of all arcs is 360, and we'll take off the 2 that we know. So if I subtract, I get 270, and let's take off 144. So we'll subtract. So I get 6 to 126 is the arc. Okay, and I don't have to split it up into two parts. I don't know they're equal or anything. I know that entire arc is 126. So if I have the arc, we can take half of that to get the angle. So I got 63. Okay. Let's do a couple more if you want to get the idea. So this question is going to review last week's topic as well as this week. So it says find the measure of angle BOC. So B to O to C. I'm looking for this one, which is actually a central angle from last week. So let's just start off with what we know. I know this angle is 55, and since it's on the circle, that's an inscribed angle. So I'm going to go ahead and extend the sides. So if I know double that to get the arc, 110. Now, if this is still the arc, it's related to that central angle from last week. The angle and the central angle are the same. So this angle is also 110, and that's what they want. All right, so let's look at the next example. We have the measure of angle B. So here's B, and we're looking for this, which is an inscribed angle since our vertex is on the circle. But this one, AB, goes through the center. So remember, that's a diameter. So half of this circle has to add up to 180. We know from B to C is 150. So if we subtract those, that will leave us with how much A to C is. So I got 30. So if the arc is 30, we're going to take half of that to find the angle. So half of 30 gives us 15. All right. And our last example, it says find the measure of arc AC. So I'm looking for this arc. All right, so we've got an inscribed angle of 30. If we double that, we can find the arc BC. So 2 times 30 is 60. And I noticed that this diameter goes through the center. So AB is a diameter. That means half of this circle is 180. So if the whole part is 180, we can take off the 60 that we know, and that leaves us with 120. Now, it doesn't look like it's drawn to size, and that's okay. Mathematically, we know that that arc has to be 120. Okay, so give those problems a try and email me if you have any questions.